Hello, people of the internet. First, please let me say that I'm genuinely surprised how many views and comments the videos in this series got. I didn't share them anywhere, and I didn't uh, like say anyone, tell anyone about them. So I'm genuinely surprised that you found them actually. So if you are watching this and you want to put a comment, how did you find the video? That would be great because I'm like surprised. Uh, that being said, I'm quite happy about that. So thank you all, and let's get to another one. Um, in previous videos, we worked on image builder a little bit. We use it in Copper to build our builder images and then upload them to the respective clouds. We already use image builder upload to upload the results into AWS, and I already implemented support for the upload command to upload the results to libvirt. So we will migrate to that shortly in Copper. The remaining clouds that we use in Copper and I personally want to implement in Image Builder is like a general OpenStack on premises and IBM Cloud. IBM Cloud will be the hardest because I know it uses some, at least we use some proprietary IBM tool to upload the results and so on. So I want to keep this as the last step, but that being said, it will be the most important for us actually because it will allow us to drop a lot of custom code at our site. But today I want to work on uploading into the OpenStack. It should be easy. Yeah, as I said in previous videos, I don't know Go at all. I'm mainly a Python guy, but I know a few languages, but I don't know Go at all. So I asked for help, and basically this is what we use currently in Copper. We just call this command. It should be easy to re-implement with this. So we will try to do that. The question is it worth it even, like replacing this simple command? I think so, because then we can have a CI which uses only the image builder command to do everything. I think it will be easier for us. And if not, I mean, it doesn't hurt anybody if image builder supports more clouds. So if it's not used by Copper or not helpful to Copper that much, I don't mind. It will be useful for other people, definitely. Because now we have like glance for this, we have IBM Cloud command for IBM, we have some other command for something else. And if you are new, you need to learn all of those. And if there is support for image builder upload, then you can just image builder upload -to OpenStack, libvirt, AWS, and it's simple. So it will definitely be helpful. Give me a sec. I need to I need to close the Slack in another window that is currently not being recorded. So like this, okay, so we are back. Okay, let's go to coding. And no pun intended. Let's go to coding. This is our image builder project. Oh, this is a copper image builder. No, I'm not interested in that one. That's a different project. We want to go to Git image builder CLI. And you can see we are on AWS Stack. This is what we worked on the last time on stream. So let's check out main and pull everything. Stash pull and stash pop. This is an important line because this allows us to use also images repository from Git, not a released package. That's important because image builder, at least as far as we are concerned, it is split into two repositories, two Git repositories, image builder CLI and this library that knows how to work with clouds. So we need to work on both of them at the same time. So we are here and we can check out B OpenStack. Switch to new branch OpenStack. Good. We will do the same for our images. So you can see I'm on AWS Stack Slices because I did some work on that. And we will check out main and we will rebase and we will check out OpenStack. Switch to branch. Good. So we have these two ready. What now? Now let's jump here and let's keep images on the left. No, let's keep image builder on the left and images on the right. So this will be, image builder on the left, images on the right. Good. So this is correct. And now we can, as you can see, there is this directory which has subdirectories for every cloud. The IBM isn't committed actually. I was working on it a little bit on the side, but this is not in the repo. So we can create an OpenStack here, right? And we can basically do the same that AWS Cloud does. That one is I consider it to be the standard, but it's a bit complicated for some stuff. Because, for example, I wrote the libvirt one, and it's like 100 lines of code, so it's not. We don't need to actually split it into multiple files and so on. So I would use the libvirt as a template. So maybe let's split again and open the libvirt at the right as the template and go to OpenStack, create OpenStack Go. Okay. Now let's use, because we need to implement the same interface as this. So it's not that much, it's not that of a stretch to just copy everything. And maybe let's keep just only this one line, uploading to OpenStack. and remove everything here, and return nil is needed too. So this is not part of the interface. This was just a help function. This is not a part of the interface either. The interface is just this. Now we need to change everything from libvirt to OpenStack. So OpenStack. This one will be, I think my LSP doesn't work for Go, right? If we do OpenStack uploader, yeah, it doesn't work. I don't know why. It can autocomplete, it just cannot rename. It's weird. So OpenStack, this is the same one. New uploader. So we have OpenStack uploader and we have OpenStack uploader. Also here. So if we search for libvirt, there shouldn't be any, only this one. Okay. And we also have the argument lu, which is a short for libvirt uploader. I don't know, it seems in Go they shorten the names to just tiny abbreviations. I'm not quite a fan of that, but we are going to adhere to the standard. So in this case, libvirt uploader, OpenStack uploader, so it will be OU. Good. And this should be a working interface. I don't know if we need to keep those or not. Let's just keep them and try to compile. Let me switch music on my second screen. Okay, good. So we will also need to change these, but we can do that right now. We can do that right now. So if we take a look at the command that I said that we use currently, name of the image, disk format, container format, I don't know what this means, and the path to the file. So we definitely need to use this is the name of the volume, name of the image, name of the whatever. Let's take a look here in the OpenStack. This is the OpenStack that we use and that I want to upload to. So in the interface it says images. So this is an image name. So is it fair to say image here? I think it doesn't have any pools, probably. So let's keep it out, and it definitely need to have some connection because like we are at this instance and you can have as many instances of OpenStack as you want to. So somehow an instance or connection or a host name or something like that needs to be passed. Okay. So let's keep just those two, and we will update accordingly. So we worked on images. Now we need to work on the image builder, which is on the left. So here, let's take a look. What did I do when I was implementing libvirt? We basically need to do the same for OpenStack. So I added some command line parameters. Set no wrap. Basically these. So we can definitely copy these, and maybe not all of these. Let's copy just one and do OpenStack connection. Okay, fine. No, let's throw away the connection because I don't know what it will. No, I'm sorry, I'm not decide. If you can, what are you if you cannot decide? Undecidable, probably no. Undecisive. I'm sorry for being undecisive. So OpenStack connection, this is a default, I think, and an explanation. So let's put just to do here, and only for type OpenStack. And here will be OpenStack image to do only for type OpenStack. So we have this. Now this is an import, we don't need that. We probably want to define this one. So libvirt new uploader, OpenStack new uploader, which will be OpenStack new uploader. Somewhere here we probably import libvirt, yeah, here. So we will import also OpenStack. Okay. So that's OpenStack. Now, if we take a look at the code previously, so this was a special case, but this definitely is something we need to do. So we have this switch statement, and we need to do the same here. OpenStack uploader for OpenStack. The same parameters are passed in every case, so we won't change them. And we have uploader for oh, by the way, this is uploader for CMD AWS. And here's uploader for CMD AWS, but uploader for libvirt. It should probably have been a CMD libvirt. Sorry about that. So maybe let's do CMD OpenStack and hope somebody or us will fix this later. I think it will be good to adhere to the AWS as a here. So OpenStack, and this is the uploader for libvirt. See, so we can do the same for OpenStack. I know this is a lot of copy pasting. And maybe it could be abstracted somehow. I don't know. I don't know Golang. So is this a appropriate amount of copy pasting or like the similar code patterns, or would you abstract this? In Python, I would probably abstract this. but I don't know, maybe this is the standard for Golang, and because they use a simpler language. I don't mean easier, I mean simpler, and they use it intentionally. So maybe this is the perfect amount of simple. Maybe this is good. But even if not, let's just copy paste this until a clear pattern emerges, and then somebody, likely not us, will abstract this. Because like I'm not the project owner, I'm not the main developer of the project, we are just contributing a very simple, small contributions, so I don't want to reorganize their code. They will do that when they feel the need. Anyway, we have our uploader for CMD OpenStack, I said. Now, the connection is something we have, but it is OpenStack. We don't have the pool, so we'll remove the pool, and we don't have volume. We have rename. Does it work here or no? Image. Here it works. See, the LSP just cannot rename classes or functions for some reason. I don't know. Anyway, the pool isn't here, and this is of course OpenStack, and we should use our OpenStack new uploader. Good. And if we scroll down, that is all. So now we should be able to go to CMD open CMD image builder and do go build. Nice. That means we changed something because it doesn't work. OpenStack in our images repository. So as you can see, we are compiling just once. It compiles also the library. So our error is in the library line 10, 24, and 25. So here 10, 24, and 25. 24 and 25. Of course, because we don't have volume here, we only have image, and we don't have the pool. So go build again. And this is imported but not used. So this is, I don't know what olog is. You can take a look quickly here. Olog failed to free pool. Okay, so this is probably some library of theirs or a package of theirs. I mean OS build to print errors. Yeah, log. Okay. We will probably have to import it back because we will log in a few seconds. So let's just comment it out instead of removing it. Go build. So not enough arguments in the call to OpenStack new uploader, which is upload in the image builder project, and it's upload go 166. So this is here. We have not enough parameters. So let's take a look how we define that. And this is OpenStack new uploader. Okay, so let's jump back, and this is the new uploader. You can see, and this takes the arguments. So we have connections. We don't have pool. We have image. Now can we build this undefined volume? Where? OpenStack 24 here, because we have image Go build. And we compiled, good. So our template is fine. Now we should be able to, I need to find some raw image. Let's do ls download, no, ls git copper image builder. Results or something like that. Output image discro. So probably this one. Okay, we have that one, and if we, so this is what I used to test the libvirt uploader. So we will use OpenStack here. We will have to use a different image, which is this one. Arch, let's specify that also. Libvirt pool, okay, so we don't have pool. Libvirt connection, so we have OpenStack connection. We'll put just the to do here, right? Later we will need to pass something like this, but later. Libvirt volume, so this is the name of the image, so it will be OpenStack image. And if we run this, we should be able to see uploading to OpenStack and then finished. OpenStack volume is not accessed but not defined. Okay, so we probably messed up some. Yeah, see here, OpenStack volume, OpenStack image. And we need to recompile that, so go build. And once again, uploading to OpenStack, and nothing happened, and we're finished. Perfect, that's what we wanted. Good, actually. Now, I would probably just commit everything as a work in progress. The reason being, we will start to, this is definitely the starting point for us. Like, this is the minimal code that we definitely need. Everything we will add on top of this is opinionated and like implementation detail and like whatever, but this, and could be critiqued, but this is the minimal skeleton that needs to exist, and it's not questionable. So we will commit that, and we will commit that just work in progress. It's not that we don't have to overthink that. Same here, but we will not commit that one replace change. I will tell you which one. This is what we won't commit. This is only a development change. So we'll commit this as work in progress too. Okay, now we can safely code and not worry that we fuck up something. So let's jump back to the ChatGPT, and we will basically just take all of this. They have it in main function, which is basically our upload and register function. So we will put it right here. So the check function, it should probably check the credentials and check whatever, but if it's nil, then whatever. We will always assume it's available, and we can code our upload. So if we keep this, it's fine. So this is the only place we need to focus on. Now, load credentials from env or config. This is the part I'm not sure in, like where are our production credentials? So I need to find them and try to use it. Oh, by the way, this uses OpenStack. So I forgot to import this. So we need to put it here also. And the problem is our package is called OpenStack and this is called OpenStack. So we need to do the same hack that we did here and basically create our local name for the OpenStack. So in the spirit of LV here for libvirt and short abbreviations in Go in general, let's do OS for OpenStack. The images here hopefully won't collide with our images, these images. We will see. And let's switch the imports maybe so that it's like the named one is the last. I don't know if it means anything or no. So OpenStack, we need to rename these three to just OS. OS. Okay. It should be. Oh, OS was a bad idea because OS is here. But that's what confused me. It's not in imports. So how is it possible to use it there, guys? Is like some modules are not needed to be imported or what? So OS is a bad idea. Let's do OStack. Sounds fun, kind of funny or not? We are 13 years old, so OStack. Stack. So it will be here stack. Okay. It should be compilable now, hopefully. So go build. It's not compilable. No module provides. We need to download the the packages. And do we have to download them, like all of them manually, or is it like command to download everything? For example, go get only. Oh, looks like it. Good. Okay, we downloaded. So go build. Yeah, so okay, so this is a typo. We can start that. OStack. And it was in one of them I missed the C. It was OStack like this. So stack go build. Undefined OS and undefined image upload. Okay. So can we just import OS like this? Probably can. And undefined images upload, which is 7.8. Images upload. What's images? So maybe it collides as well. So I don't know, because it works for images create opts and create. Just the upload doesn't work. So this is not on us. This is fuck up from our friend ChatGPT. So there is this image create, we have that, created images, and now we have the, we open, yeah, that open is here too. So this is image data, okay, whatever. So this is the only part that changes. We can remove this. I guess we don't have image data, yeah, as expected. But we can import it here, good. Okay, image data, I guess we will need to go get, or no? No, we compiled, good. I'm surprised, actually. So, and now we need to, now we need to test this. First of all, if we, what happens if we run this? So a crash. Okay, missing environment variable. Okay, so I was confused why we get the traceback, because I thought that Go programs don't runtime crash, but yeah, that's on us. We have panics here. We will need to log these later. But later. Now I want to do only one thing. I want to, first of all, we open this raw file. I want to be specific about that. So if we fprint f status, I don't understand what status is doing here, but don't mind that. What if we do, I have some formatting here probably. So we use the olog here, so let's use it also here. Let's uncomment this, and it was olog fprint printf, and we have image, and we should have an OU. No, OU is the image name. We want the file, and we have the reader. Oh yeah, that's the thing. We don't get the path to the file. We already have the reader. We cannot open like this. Hopefully we will be able to pass just the reader here instead of the file. If we take a look at the libvirt uploader, there is this upload for a given size, but then we send in the yeah, this is the most complicated part of the code. Okay, so no, let's not do it this complicated. Let's just hard code the variable that we wanted to use, and we will somehow get to it when needed. So this was our raw image. This was our raw image. Now, how big the image is? DUSH for this is 3 gigs. So we should be able to probably test this quite fast. So we have this. We will go build again. olog again. I don't like this fact about Go that you cannot have unused imports. Not very much friendly for development. Go build. So now we need to somehow connect to the OpenStack, and once we do that, we should be able to upload actually. So let's take a look at the development instance, Copper backend instance that communicates with the OpenStack in production. It's a staging instance, but we could also take a look at production. So SSH, this is a production one. So let's use the development just to be sure. Let's clean this, and so our user, which is called Resalog, is responsible for spawning images inside of that OpenStack. If we do Resalog main resource list grep also, see, this one is started in the OpenStack. So this user somehow needs to be able to authenticate and communicate with the OpenStack instance that we need. So if we take a look at etc resalog server and pools YAML and find also, this is the instance, and it runs this command to spawn a new instance. So maybe I don't know what's the Resalog VM IP2 YAML. That's a bit strange to me. But if we gf to this, so it seems this probably contains our what is it called, authentication keys and so on. Let me take a look at it on a different screen. Okay, so you will see Emacs and I will see the keys. Good enough for you? GF. So I can see it exports OS auth URL, and it's the one I need. It has some project ID, project name, user domain, OS project domain ID, some tenants, regions, username and password. Okay, so this is exactly this is exactly the file that we needed. What shall we do now? I will jump to my main demax session. I will create a script called OpenStack auth, and it will be also OpenStack auth.sh. I will copy everything. I need to do set paste because I'm in Vim, because you are in Emacs. I'm closing it, I'm chmod xing it, and I'm jumping back and closing this. So give me just a second. Here. Okay, so we are here on my machine. There is this OpenStack, also OpenStack script. If I execute this, it will export all the OpenStack variables that I need to connect. I think I need to run it. My thinking is, with my luck, it will print everything it actually does. So it will actually leak the keys to the console when I run it, I think. So let me just give a sec, and I will run this script off screen. Yeah, I ran it. Okay, it didn't leak anything. Okay, good. I think everything we do from this point we can do on the record. I definitely need to, after the recording, I need to go see what variables it exported, and I need to destroy them so I don't have any production-like stuff on my machine. Now, what do we want to do? We actually want to try the upload, no? So, fingers crossed. Okay, we trace back. Which is strange, because OS auth URL. Let me echo this. Okay, it's okay. Maybe I cannot. Let's jump to not copper. Let's jump to SSH, and we were here. And this script, I wanted GF actually. This script does. Okay, so is dot actually executing, or this means source, right? I did this. Should I do this? Does anything change? It does. Okay, so I needed to not execute but source it. Okay, so now maybe do go build once again. I'm not sure if I changed anything or not. And do this. Okay, so you must write exactly one domain ID to authenticate by username. Okay, do we have domain here? We don't have domain here. Where should I provide it? So panic. Okay, this panics where? Dom, okay. Strange. And it would be nice to see the line. So upload, okay. No, this is image builder still. I want this. So 51. Here, this is the panic. Okay, so we are not authentified. Now, what's wrong? Let's take a look off screen at the auth file. So if I search domain there, so we have some domain. Okay. The traceback was, it seems that I'm defining two of them actually. So I think this part can be, let me open a scratch buffer and I will put here everything that we see except for the passwords. Fair. Set no line, set no number, so we can easily copy paste. So shit. Okay, good. I think we don't need any more than this. So you can see it project ID, project name, user domain name, and this is the fun part. So is it possible we have both of them and that's the problem, or so we have. Yeah. Okay, so if we take a look at the, we logged out, copper team. I don't want to show you my Bitwarden. I'm sorry, this is not going as I wanted. There's so many off-screen stuff. We wanted to see some programming, won't we? Didn't we, actually? 5, 8, 6, 7, 3, 9. So we logged in. No. No. 5942. So I'm in Bitwarden. And here is the password. Bam. Login. Closing Bitwarden. And jumping here. Images. Yeah, this is the images. What was the original goal of this? Yeah, I wanted to see the if this is, which one is like correct. If we open something like this, the domain isn't written here. RC file, okay. Help settings. Okay, let's try to. What was the traceback? You must provide exactly one domain ID or domain name. User domain name, domain ID. Let's unset this then. If we unset this, it's unset, and if we run image builder, but this is annoying because we still have this, don't we? We have. You must provide exactly one of domain ID or domain name to authenticate by username. Did we? So let's try to paste this into our ChatGPT. Maybe he knows something. If we are sourcing, you should have variables like this. Important ones are project name and this. Yeah, this is our OS user, and this is the one we unset, isn't it? Oh, it's name. It's name. Okay. Okay. I'll try that. What if we download the OpenStack RC file? And we ls download, how is it called? Fedora copper open something. Fedora copper this. So if we source this, please enter your OpenStack password for project. Okay, we need to go. Yeah, you don't see what I type. We need to. Shit. I didn't want to show this. We need to go back to the vault. And we need to take a look at the also. And we need to take the password and put it here. Okay, we did that. Good. Now, can we run this? Still the same error. Okay. This is not being funny anymore. Oh, it wants here. Do we have auth options here? Auth options from env. Yeah, this is. Go for cron or scope. Yeah, I want to parse it from env. We did that, didn't we? So yeah, we sourced. We have the exports. The key ones we were missing before. So if we take a look at this and take a look at this, not the variable. So we have both of these defined. All options from env. We do this, don't we? We have all options from env. So we have that. And this is the one that fails. So what's the fucking problem here? If you run this after sourcing, it will work the same. So go build once again. I sourced, but it still prints domain related not being set. Yeah, I don't want to. If you don't see, I have these. So I think this will be a good place to stop the recording actually. We are at 1 hour. So we are here. I will debug this off screen because this will involve a lot of like investigating the private keys and so on. So I would have to switch on off and again from the recording and yeah, it will be boring. So I will investigate the keys afterwards and figure out the auth. Then we will continue working on this, and we will successfully upload to OpenStack. Then we will have to use the reader here, which will be a problem because we don't the reader cannot like they give us this. So we will have to invent something like this. Hopefully it will work and like upload by reading the reader and sending the data. So we will have to do that. And then we will have to make this configurable and passable from the command line, and clean up the code a little bit. But yeah, that will be the next plan. But we will have to figure out the auth first. Now I'm thinking maybe we can do this. Maybe we can continue here. If we go to, yeah, let's continue here. Let's not upload. Actually, finish the upload. Let's just do all the smaller stuff. So to have a victory at the end, you know. So if we take a look at, yeah, this is where I wanted to go. So we have this. We will definitely need to we already have the image. This will be it. Disk format. So the disk format can be actually read from the exception of the extension of the file. Maybe let's have an explicit argument for that. Why not? OpenStack disk format. Format. This will be better. Only for OpenStack. And OpenStack container format. Only for OpenStack. Now, we did some parsing, didn't we? So, if we take a look at our work in progress, we did some parsing, which was this one. So, we now have OpenStack disk format. This will be disk format, and we now have container format. Container format. Why does this complain? Wrong, not enough. Are you sure? If we go build, the LSP have some problems, but it's correct actually. So we will do the same trick that is used for AWS. You can see they pass opts, and we will do the same. We will have opts, and the opts are created like this. So we will do this. Now, we want to use AWS Cloud, of course not. We want to use OpenStack uploader options. Now, this doesn't exist, first of all, and we don't want to pass these. Maybe we want. Maybe we want to. Target arc, boot mode. I'm not sure. We can keep it. Here we have target arc stir, and here is target arc stir. So the target arc is created from it. Okay. Okay, so maybe let's do the same. Like this. Wrong here. So we have this. Okay. So we can pass these two. We also want to pass disk format, which will be disk format, and we also want to pass container format. Container format. I think they align stuff like this. but the linter will probably do that for us. Now we pass the opts, and we don't know what uploader opts for OpenStack is. So we are in the OpenStack here, and we want to take a look at the AWS cloud. What did they do? Is it here? Uploader? No. Just uploader options. It's here. So this is right below the AWS uploader. So it should be right below this. Uploader options. Boot mode is set for the AMI. If nil, boot mode will not be set. What if we don't do this? And remove them as well here. I don't know if it's needed or not. It can be added if needed. So we want the disk format, right? Format, which will be a string, and we want container format. Container format, which will be a string too, like this. So uploader options exist, so this should work. Only LSP should be failing, but unknown field, container format. But does have container format? Is it a typo? It is a typo. Too many arguments to call OpenStack new uploader. Yeah, makes sense, because OpenStack new uploader is here, and open new uploader, this it should be opts here, but let's take a look here. So yeah, in AWS they do the same, and they have opts like this, and then they so then they don't pass the opts actually anymore. They just say that, for example, container format equals opts. Now this is with a capital C. Container format, like this, comma. So we'll have disk format also. Disk format. Disk format. Maybe let's realign this. So new uploader, it does this. Now let me think. Yeah, because it creates the uploader, so the values actually needs to be here also. So we need to have disk format, which is going to be a string, and container format, which is going to be a string too. We need to realign this. Okay, can we go build now? We can. Beautiful. Beautiful. What now? Now we can use the values here. So the image name is actually, we have the uploader and its image. So image name is actually OU image. Image. This will be OU disk format. And by the way, what was, we need to set the defaults for these. So somewhere we do the command line arguments. So we could set the defaults here, or maybe we can set the defaults here, but thinking about it, maybe it needs to be on both places. So yeah, let's do it here. If they want, if by they I mean maintainers of the image builder project, if they want to have default specifically for the library, we can do that. But disk format, we can put the default here, which is raw, and container format bare. That's good enough for us. And OU, because personally I don't care about using the library on its own, I care about image builder. So I'm taking a look from the point of image builder. A good maintainer of the library should see all the use cases and try to find the best solution for the library itself and library with the combination of the image builder. So that will be for somebody else to decide. For us, this is good. Disk format OU container format, right? So we use all of these. For some reason, this is here twice. Good. Upload complete. We will later need to remove this. We have these. We need to remove the comments because this is just AI explanations, but they are not very much useful for people. I think we can do it like this. Opts, create image created. Now we have the upload. So we will have a big to-do here. Python comment. Big to-do here. Read the data from the reader. Now these panics, if you take a look at libvirt.go, for example, there are no panics. If something goes sideways, we return formatted errors like this. So we will do the same. Panics need to be replaced. So we will return error failed to read OpenStack and env variables. This is good enough. Next one. failed to authenticate to OpenStack. Good enough. We have new image service v2. I don't know what this means actually. To do what does this mean? New panic create. So this is I don't know what does this mean actually. This is about opening the file. This will be removed because we will be reading the reader. And this is this will this is a part of the piece that is going to be replaced. So we replaced those. We replaced what we needed to replace. Now container format undefined, line 67, that will be again lowercase error. Go build. Okay, so good. We did a lot. So we are definitely going to stop the recording here. I need to figure out the authentication after this, and I need to use the reader instead of reading the file here. That's it. I need to write the proper descriptions, and that's it. And we will have the OpenStack uploader. So as you can see, we didn't run the code many times. This is actually very, very, very different workflow than I do normally. Normally, I'm in Python, and normally I live inside of debugger. So I usually just run the code with the debugger, and I just take a look what values and types my variables have and use them accordingly. So it's a very interactive and try and error kind of approach. I like that one very much. But the problem here is like uploading the stuff takes a lot of time, and uploading takes a lot of time, and also like we had the auth problems, so we actually couldn't like try and error the stuff. But Go and other static typed languages are very good in this, like in this different approach, not the try and fail one or try and error one. They are very good at like in the if it compiles, it probably works approach. So all of our types match, and we can expect this we can reasonably expect this to work once we run the program. So yeah, I'm glad I could try this approach. I tried it when I was coding a side project in Gleam or in Elm, and it was perfect. It was literally, if it compiles, it works exactly as you want. I don't know how is it possible, some kind of black magic for me as a Python dev, but it worked that way, and it's kind of fun to use that approach sometimes. Personally, I still probably like the everything is a mess and I'm in a debugger and I can check everything and behave according to that approach. But yeah, you need to try everything, right? Anyway, that's it. See you in another episode. And if you want to comment, how did you find the videos, and if you enjoy them, and put some feedback there, it would be perfect. Thank you very much, and see you next time.